type of series we are going to discuss? Taylor series. So here series comes. It means sigma will be there. Okay. Sigma means summation. This is called sigma. Sigma. And this is used for summation. Sometimes this is also called summation. No, no. This is a symbol actually, and this is written as capital. There is no concept of a small sigma. Okay. So first type of series we are going to discuss is what? Taylor series. This is f of a x minus a f of a upon 1 factorial x minus a square f double dash a x minus a cube f triple dash a upon 3 factorial x minus a 4 factorial and so on up to infinity, right? Okay. This is this is a series. Why? Because between each term there is a plus sign, right? Yes. So you can write in this way. This is summation. So you can write sigma. Okay. Here 0 factorial, 1 factorial, 2, 3 factorial. It means that this is n factorial, right? And n starts from 0 to infinity, right? Understood? This is first time derivation, second time derivation, third time, fourth time, and this is no derivation. It means that, understood? Okay. This is x minus a raised to 1, x minus a raised to 2, x minus a raised to 3, x raised to 4. And this is what? X minus a raised to 0. Because anything raised to 0 is 1. So you can write x minus a raised to 1. Right? This is general form. You can, when you combine all these terms, you will get like this. Okay? Understood? And this type of series is called Taylor series. Okay. Its application is any function can be changed in the form of series. You can, yes, you can change according to your need. Suppose uh, this is a function. Let's suppose x cube plus 5x squared 2x minus 9. Suppose this is a function and you want to change this function in the form of in the power of x minus 2. Okay. So I am writing here change fx in the power of, let's suppose x minus 1. Okay. So this is this function is in the power of x, right? But I want to change this function in the power of x minus 1. So how can you write? This can be done using Taylor series. Yes, yes. So now you can see this series is in the power of x minus a, right? Na? And you want to change this function in the power of x minus 1. Yes. So you can say a is equal to 1, right? Right, understood? So first of all, find f of 1. 1 cube, 5 1 square, 2 1, minus. So 6, 8, minus 1, right? Now we differentiate this. First time differentiation will be 3x square 10x plus 2. And f dash 1 will be 3 plus 10 plus 2. Right? Now we find double derivation. 6x plus 10. Because differentiation of constant is 0. F triple dash. You cannot differentiate further because differentiation will be 0. So this function can be differentiated 3 times maximum. Right? Understood? Okay. So fx is what? F of 1 plus x minus 1 f dash 1, right? By using this formula, x minus 1 whole square f double dash 1, 2 factorial, x minus 1 whole cube f triple dash 1. Okay, because you are differentiating this function maximum 3 times. So we can write up to here. Okay, understood? Now you can see this is f of x. F of 1 is minus 1. F dash 1 is 15, right? 15 upon 1 factorial. X minus 1 whole square. F double dash is 16 upon 2 factorial, right? X minus 1 whole cube. F triple dash is 6 upon 3 factorial, right? F of x is what? Minus 1. You know what is the value of factorial? You know what is factorial? You know 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 into 2, 6. Yeah. So I can write this 15x minus 1. This will be 8. And 3 factorial cancel, right? Okay. This is your answer. You can say that now you can say that this function is converted into this form in the power of x minus 1. Okay, if you want to prove that the actually this function is actually the value of this, yes, you can derive, you can also prove how. Open the bracket and simplify these. When you open the bracket and simplify, you will get like this. Okay, but there is no need to open because you have to express this function in the form of x minus 1. Okay, and even not in power of x minus 1, you can express in any power of x. You can also write x minus 10 raised to power. Okay, and this can be done by using Taylor series. So the function may be any type. It is not important that this is a algebraic function. You can also express e raised to x. Okay, any type of function you can express in the form of x minus a power. In left hand side, you can see the series in the form of fx, right? But in right hand side, you can see series in the form of x minus 1. Right? Right? Understood? One more example I explain. Mu 2. Okay. But you understood, right? Okay. Express Ex in the power of x. Express means what? You are finding a series in the power of x. Okay. Here in the power of x, not in the power of x minus a, right? In the power of x, right? So in the power of x means x minus 0. Okay. So a is 0. Okay. Fx is what? E raised to x. So f of 0 will be e raised to 0, 1. F dash x, you know e raised to x derivation is e raised to x. Okay. F double dash x. F triple dash x. You know the derivation of ex is always ex. So each time you are getting 1. Right? Now you know the formula of here a is 0, right? So you can write 0, x minus 0, x minus 0 whole square, x minus 0 whole cube, and so on. If fx is what ex, what is the value of f0? 1. X minus 0 is x, f dash 0 is 1, x minus 0 whole square is x square, f double dash 0 is 1, x minus 0 cube is x cube, f triple dash 0 is 1, right? Okay. So e raised to x becomes 1 plus x square over 2 factorial, x cube over 3 factorial. This is your series for ex in the power of x. Understood? Or you can say Taylor series is used for changing any function into algebraic function. This is what? Algebraic function. This is exponential function. Yes. This is what root x. And this is what? F of x. So f of x is what? Root x. Right? You can also write x raised to half. At x is equal to 4, it means that a is equal to 4. Okay. And after finding this, find the value of root 5. Okay. See. You know f dash x is what? Half x, half minus or minus 1. X raised to minus 1. Right? F double dash is half minus half. X raised to minus half minus 1 is minus 3. Right? And f of 4 is what? Root 4. F dash 4. This is actually what? Root x in denominator, right? Yes, when minus half in power, it becomes denominator, right? So this you can also write 1 4 minus x raised to 3 by 2 in denominator, right? So minus 2 raised to 3 by 2. Okay. 2 raised to 3 by 2 is what basically? 2 raised to 3 is 8 raised to 1 by 2. It means under root 8, right? And you know under root 8 is what? 2 root 2. So this becomes 8 root 2. Okay. Now use the formula. What is the formula? Okay. F of x is root x. F of a is 2. X minus 4. F dash a is 1 by 4. F double dash is upon 2 factorial. Right? This is your series in the power of x minus 4. Okay. And you are also asked to find root 5. So when x is replaced by 5, it becomes 2. 5 minus 4 is 1. right? 5 minus 4 is 1. Okay. Now, when you calculate this, you will get answer. 2 plus 1 by 4 is what? 0.25. And this is minus. When you calculate this, you will get in points. So, approximately you will get 2.25 like this. Okay. This will be your answer. This will give you approximate value, not exact value. Because you are taking up to third term, right? The more terms you will take, the more accurate will be the answer. So, yes. Okay. Yes. Sometimes some uh, value cannot be calculated by calculator. So we use what? Taylor series. Okay. For example, if I ask you what is the value of log sine e raised to pi by 4. This value cannot be done by calculator. So in this case, what we use? Taylor series. Okay. So first we change this function into Taylor series. Then we put the value of x is pi by 4. But when you insert this value into computer in Google, the Google will change this into polynomial. Then it replaces x with pi by 4. Okay. Directly, it will not calculate your value. You will get final answer, but in background, when you ask in details, it will show up by Taylor's image. Okay. 10th degree and center at x is equal to 3. Okay. So f of x is equal to 1 upon x. F of 3 will be 1 upon 3, right? F dash 6 is 1 upon x square. 3 square means 9, right? F double dash 6, you can write minus 3. Minus 3 is what? In denominator. Okay. Minus 6 upon 51. 24 upon 243. 8 over 51. Okay. So up to 10 times you have to derivate. Okay. So function becomes 1 upon 3 x minus 3 2 upon 20 minus 2 upon 27. If you understand, then no need to write up to infinity. Sometime it is asked 10 times, 3 times, 4 times. If nothing is mentioned, then you can write up to infinity. Maximum 3 to 4 times you derivate and then write dash dash dash.